So my name is Georg, presenting joint work with my colleagues Felix, who's also here sitting in the front row, and Alyosha. We work at DFKI, the German Research Center for Artificial Intelligence here in Berlin. We have several different sites. The Berlin site is the smallest, but the best, of course. Web annotations, a game changer for language technologies, is indeed the kind of use case presentation, and I would like to also thank the program committee, of course, of I Annotate 2016 for having us here present our work. So you know what the web is. We don't need to talk about the web, but maybe I should very briefly explain in one slide only what language technology is. So this is LT in one slide. Language technology is a set of heterogeneous and evolving applications that usually involve either the processing or the production of human language, either spoken language or written language. That includes a whole set of different applications. Maybe you've heard the buzzwords: natural language processing, NLP, computational linguistics. Linguistics itself plays a big role in here. Computer science, of course, cognitive science, AI, machine learning, the big new deep learning craze, and all of these different fields converge in language technology. And our methods usually work on big amounts of language data. We call them corpora, by now often on a web scale level. Our methods are typically statistics-based, machine learning, deep learning, or still often rule-based, coming back to the AI of the 80s and 90s with methods that use grammars, for example. And we often have the need for human experts, linguistics experts, to analyze and annotate data. We've been annotating data even before the web. So in the 60s, 70s, people have been annotating using very special tools, smaller or larger amounts of language data. So a couple of applications. People always like to say that language technology is IT's best kept secret because it usually operates behind the screen and behind the scenes. Spell checking, grammar checking is obvious. Search engines, by now Google, we can say that Google is a language technology company because there is so much language technology involved in Google itself under the hood that it is, to a certain extent, just that. Interactive personal assistants, a whole different category. The likes like Cortana or Siri or Amazon Echo is brand new. Google just released a new product the other week on interactive personal assistants, machine translation, of course, and several others. So you know this diagram, I assume, the web annotation architecture, and now we can try to pinpoint what the relationship is between web annotations and language technology. First of all, content itself can be created using language technology. We call these tools text generation or report generation. There are many different words for what this is, or big data text generation is also one of the new buzzwords. So content automatically generated. The content itself can also be analyzed using language technology. We have seen a couple of use cases yesterday. Peter Murray Rust also presented work that involves this, the gazetteer or dictionary-based spotting of concepts in chemical articles. So semantic analysis, input for machine learning algorithms. Another big thing that we do in language technology is social media analytics to answer questions that often customers have who are very interested in user-generated content, who want to know, okay, what do my clients and customers think on a certain product? So we need to go into the user fora, discussion fora, in order to text mine them to see what the sentiment is or the opinion on a certain product. This is a very difficult, very costly exercise because there are so many different sources that we have to potentially mine, so many different formats that we need to take care of. And here a few established and widely used web annotation services would simplify social media analytics dramatically. Another thing we can also use we can also use language technology methods to actually create web annotations. For example, in a smart authoring scenario. Also, yesterday there were a couple of presentations that touched upon this, and I will come back to this in a second. So language technology and web annotations in a nutshell. We can use language technologies to analyze web annotations, to generate web annotations, to include additional background information on certain topics, on certain concepts, and the point dedicated LT-specific web annotations is referring to the scenario in which we don't have any specialized tools anymore. Linguists and computational linguists, they like their dedicated tools for very specific annotation tasks. For example, rhetorical structured trees are a thing since the 80s in linguistics and text generation, and there are a couple of editors, and they are all very proprietary. And if you could put this into a generic web annotation scenario, that would be brilliant. So 2 example scenarios in a bit more detail. How language technology and web annotations actually go together, or can go together. The first one is from our project Digital Curation Technologies. It's about the semantification of content for curators of digital information. And the second scenario is on machine translation. Just very briefly to give you the context, Digital Curation Technologies is a project in which we are building technologies, language technologies, knowledge technologies, data technologies that are meant to support curation processes in a couple of companies. You can see the respective 4 partners that we have in the project on top of the little diagram here. And the idea is to make these digital curators or knowledge workers or journalists, authors more productive, more efficient, to give them new ideas through our tech. It's a fairly typical technology transfer project in which our research results are meant to be channeled into industry and into production use. This is the scenario in a very generic form. So we have certain type of input. People are flooded with input, emails, tweets, Instagram pictures, Flickr, articles, RSS feeds, whatsoever. And then the green question mark on top of the head of this person here sitting at the machine can be analyze, write, summarize, all sorts of different cognitive processes. The person itself can be an investigative journalist or curator of an exhibition who's meant to plan an exhibition in a museum, for example, or it's a TV editor, an author, a scholar, a knowledge worker, and so on. And using a specific type of software, he or she produces some kind of output. And in a bit more detail, the different processes that are in use here. We are especially trying to support these curation processes, so structure visualization. We want to take care of multilingual information sources and multimedia sources. We want to provide recommendations in a better way. Multilingual summarization is an important point. Timelining, more on that on the next slide. Semantification, so named entity recognition and these technologies and so on. The typical architecture diagram. On the left-hand side, you have the specific, sector-specific tools and architectures and platforms of our 4 company partners in the project who work in 4 different fields. In the middle, the platform that we are building, which is based on an open source approach that is being designed, built, deployed in different fields in an EU project called FREEM that Felix coordinates. And in this platform, we have a fairly nifty way of putting together curation workflows by pipelining different e-services through a format that we call NIF, Natural Language Interchange format. And this is a fairly typical RESTful API-based scenario. So one example, if we have the fairly generic use case in which we have a very big document collection, we throw it into the machine, and we want to extract all the time expressions. For example, to provide a visual timeline of the documents, of this huge document collection. Think Panama Papers, for example. You have, I don't know, a million documents, you throw them in, and you want to have some kind of structure or order. You want to browse these documents. I don't know if our system is already able to handle a million documents, but that's a different story. But let's say 1,000 documents. Still, you want some kind of order or structure or timeline, and this time analyzer here is meant to provide just that, including some interesting features such as the average or mean date calculation of documents and so on. And we implemented this prototypically as a web annotation approach. So in goes the text. This is the text on, I think, on General Franco. And then as output, we get the output on the bottom left side here from our time expression analyzer, and this can then also be stored and put out as web annotations here in JSON LD. Okay, second use case is web annotations for HQMT. That's a four-letter acronym meaning high quality machine translation. So machine translation is a very, very interesting field. It's very difficult. It's very complex. You all know Google Translate and the Bing Translator and all the other online translators. They usually work on very, very large numbers of texts that go in, that are then being processed and then based on the input. And the input is usually not just one text, but usually two texts. So parallel text, one text in the source language, one text in a target language, and with statistical magic you can then build translation models. This technology has reached a certain plateau, so we're there more or less, and any improvements of the quality are now very difficult to get. And we are trying to advocate a new approach, which we call HQMT, so high quality machine translation, towards a scenario in which we get basically better performing, better precision, better quality of the resulting automatically translated texts. And for this we want to include not just one person who's a specialist on statistics and machine learning, but also language experts, people who work in language service providers, who annotate and who translate texts for a living. So they have very important feedback, as we know now, through certain projects. On the diagram here, you see our ideal scenario. So this is basically still science fiction, but this is where we want to go, with one larger tool ecosystem, which is fairly generic, interoperable. In the middle, by now, we are still using very, very many specialized tools that are not interoperable. Every research group is using their own set of tools, with a few exceptions, but all in all, it's a fairly heterogeneous landscape still. And we want to go towards standardized tools, towards a coherent, interoperable, integrated ecosystem of tools. And here, a centrally stored web annotations repository would be a very big step in the right direction. Actually, if you happen to be in Slovenia next Tuesday, we have a workshop on this very topic. So, and the little pitch here on the event is in the corner. So just to give you an example, we have something called MQM. Something's wrong with the cable. No more. MQM, multidimensional quality metrics, is a very, very complicated and complex approach at basically annotating the quality of a translation. If you think about that for a few seconds, quality of a translation is a very difficult thing to assess. So that's why this thing is so complicated. The people who build it usually say it looks like spaghetti, which is true. So, and the output of the tool, we have some tool support for this already, but the output of the tool is proprietary, of course. So it looks like the output in the upper screenshot here. It's a proprietary tool-specific CSV format, and it makes much more sense to have this in a web annotation format, so that you can pull it into arbitrary generic tools. And this we build basically just to show that it's able to do this, and in order to go the right next steps, and also for the workshop then next Tuesday in Slovenia. But there's something else. So these were 2 use cases for web annotations with language technologies. It also goes the other way around. So the other week we had 2 colleagues, Nick and Connor from Hypothesis at DFKI for a presentation, and we learned what's underneath the hood. So the web annotation infrastructure is an interesting, complex thing, and of course web annotations also work on language. And maybe language technology can actually help build better services and better annotation infrastructure. For example, anchoring annotations to changing content in a robust way is very tricky, apparently, because as soon as the content changes, but you have an annotation pointing into the content, there's a problem. So you want to fall back to some mechanism so that you can reconstruct somehow the former anchor of the annotation, and semantic methods here could help. For example, to semantic distance measurements, for example. So to reconstruct the original anchor of an annotation that was changed, or the annotation of copies of documents. We learned that Hypothesis is able to annotate fairly simultaneously HTML documents and PDF documents at the same time. So you annotate one and get the annotations in the other automatically. That's fairly nifty. But maybe you also want near duplicates also to be annotated automatically with one annotation only. And here language technology and duplicate detection and near duplicate detection could also jump in to help. Okay, coming to the end of the presentation, we can also pull out a vision. So a few years ago we prepared the strategic research agenda that you can see here on the slide. We had a couple of bold, grand visions for European language technology in this multilingual Europe scenario. And it would be great to have something like a next generation personal assistant who always follows you, who provides active, proactive feedback, who reminds you to take an umbrella, the old classic example, once you leave the door, and go outside. Highly personalized assisted browsing experience, maybe an assistant that is able to detect what you're currently trying to search or what you're currently trying to do online, who is able to detect your intentions and your tasks and your preferences, and who is then able to already, even before you've seen it and before you jump to the document, to annotate relevant, maybe surprising new facts, things maybe the assistant already knows what you know, and then he can point out what you don't know in content that you haven't even seen yet. And this all could be done through web annotations. And this is a fairly fascinating example that we also have on our roadmap. So, are web annotations a game changer for language technology? Yes, most certainly, if the user experience and the browser support are done right. And maybe language technology can also be a game changer for web annotations. Thanks very much. Just another ad. We are currently planning a conference, Metaforum 2016. The call for papers is still open. If you're interested in these topics, why not submit a short abstract to the conference? It's on July 4th and 5th in Lisbon in Portugal. Thanks very much.
Any questions for Georg?
It's not It's not a question, but I just wanted to point out that Georg is the guy who helped us find this space and helped organize the conference. So I want to thank him for that.
Could you just reiterate again how you would explain to someone the basic difference between what Google and Translate and Bing Translate do today and high-quality machine translation? Because it sounds... Google and Translate and Bing Translate clearly are trying to produce high-quality translations, so how would you explain to a layman the difference between the two?
The difference between the Google translator and the Bing translator?
No, the difference between what Google Translate...
What we are trying to do.
Yes.
What we are trying to do is still in its infancy. It's basically basic research. Our approach is to actually talk to the experts. The Googles and Bings of the world, they have people who are very skilled in deep learning, in machine learning, in neural networks. They know how to take apart large documents of text and how to apply some statistical magic to them. But they are not thinking about translation the way that a professional translator, for example, thinks about translation. And we are trying to go through the experts on the topic. So we talk to the translators. We have projects in which LSPs, language service providers, so companies who have on their payroll many translators, we have them in our projects, and they go through using annotation tools. They go through translations and they mark using the MQM approach where the problems are in the translations that the machine produced. And using this type of data, which is highly specialized, it's very complex, we are trying to build better tools. But we are still in the data annotation phase right now. So we are establishing the tooling in a way, talking to the people. They are now slowly accepting our approach. The translators are a bit hostile towards us, so it took a few years to convince them that we don't want to replace them. And the first technologies maybe can be expected in 2 or 3 years, the first prototypes.
A related question that might bring out more of Robert's question, which is one of the things that I've encountered with translations is that when you're dealing with like an academic text, different people will have fundamental disagreements about what a good translation means.
Exactly.
And can you support that kind of disagreement or dialogue within your system, so you can say there is not one valid translation of this?
Yeah. So there is no system yet, but it's an excellent observation. Let me try to answer the question by pointing out there are evaluation metrics in the field that are being used, but they are being used on reference translations. So the system output is being compared to a reference translation. This approach is designed for many reference translations because it makes sense, because you can translate a sentence in many different ways. But usually there's only one. So it could be the case that you produce a perfectly fine translation which doesn't correspond to the reference translation and you get an error score. So that doesn't make sense. So in a way, the translation and machine translation, especially community, has been doing for quite a few years what we call feature engineering. So they are just engineering their features to get slightly better score, and then you get a new paper, and so on. So, but the plateau has been reached now for a few years, I'd say, and it's time for a paradigm change, and we want to initiate this paradigm change.